Good morning, guys. It's Mrs. Blaylock from Golson. Today in our math lesson, we are going to be completing Lesson 5, Understanding of Missing Addends, and Lesson 6, Counting on to Subtract, out of our iReady math packet today. You will find those lessons in your math packet starting on page 11. So if you have your math packet, go ahead and get that out so you'll be ready. Now, before we start the lesson, I want to take a moment to reiterate fact families. A fact family is when you have three numbers that create two related addition facts and two related subtraction facts. For example, if you have a whole of 11, you have two parts, 9 and 2, and you can make the related facts listed below. The same with if you have a whole of 14 and two parts of 10 and 4, you could make the related facts below. Just remember that all three numbers are in every fact. You always take your two parts to make your whole, and you always subtract from your whole to get the other part. Okay, and we also talked about crazy cousins the other day. They're still related facts. They look different, they act different, but they're still in the family. Okay, so fact families are very important when you are trying to use the strategy think addition to subtract. Now, and that is what this lesson consists of. If you'll look, they give you the equation, find 6, take away 5. Now, I'm going to show you on a piece of paper how we would normally work that problem. Okay, we would say that 6 is our whole, 5 is the part where we know, and we know that we always subtract from a whole, and then we always add our two parts. So our missing part is the part that's here, and if you take 6, take away 5, they want you to find the answer. Now, normally we would draw our whole and cross out the part that's being taken away, and our answer we know would automatically be 1. So I would put my 1 here, but they're wanting you to use a different strategy and think, what does 5 need to get to 6? For example, if I have 6 cookies and I've already eaten 5, how many more do I have to eat? Oh, well, I've only got 1 more to eat, so my missing part would be 1. There's 1 cookie left because I have 1 more to eat. So there is 1 left. So going back to our computer screen here, it says 5 plus 1 equals 6. So then if 5 plus 1 would be 6, then 6 take away 5 would be 1. So then I could go back to my bond and say that my answer here was 1, because 6 is my whole and my two parts are 5 and 1. And I could also write my related facts, which would be 1 plus 5 equals 6, and then 6 take away 1 equals 5. Now those are my 4 basic related facts. So if you know that 5 takes 1 to get to 6, then you would know automatically that 6 take away 5 is equal to 1. It's called thinking addition to subtract. Okay, so then you have more problems here where you're subtracting and they're wanting you to think, what does 6 need to get to 7? 6 only needs 1 more. Okay, if you have a number line, you could do that as well. What does 2 need to get to 5? So if I have 2 fingers up, I want to know, oh, I need 3 more to get to 5. So you could use your fingers as well. Okay, so you have number 4. It says 6 take away 4. They want to know, what does 4 need to get to 6? Here, 8 take away 4. What does 4 need to get to 8? And what does 7 need to get to 9 to answer 9 take away 7? And it says, write an addition equation that helps you find 6 take away 3. Then complete the subtraction equation. Again, these are related facts because your whole is going to be 6. The part that you know you're taking away is 3. And they want to know the part that is left. It says, how can an addition equation help you solve a subtraction equation? Okay, well, it helps you because if you know how to add, then automatically you can subtract because you're using those same parts and the same whole. Okay, so we're going to go ahead and skip on into the next lesson. Okay, so in this lesson, we are working on the same strategy, except you're using the number line to help you add. Now, that is one strategy that a lot of my students enjoy using. Okay, so here they want to know what's 5 take away 3. And now we could use our finger and we could say 5 take away 3, and we know our answer is 2. Now, this is an easy peasy equation. So you could start at 5 and take away 3. 1, 2, 3, and your answer is automatically 2. But you can also start at that 3 and count up. 1, 2. Now, counting up to 5 was a lot quicker than starting at 5 and counting back 3. So that was a more efficient way or strategy to solve that equation. So 3 plus 2 is equal to 5. So therefore, 5 take away 3 is equal to 2. Okay, so here, let's try the starting at 6 and counting back. Some students still like that strategy. 6 and you count back 4. Because it's 6 take away 4. 1, 2, 3, 4. My answer is 2. Now, that took 4 hops back. But they're saying if you start at 4, you can count up. 1, 2, because it's only a missing part. So counting up was a quicker strategy than it was counting back. So both strategies work. It's all about finding the correct answer and the strategy that works best for you. But we do want to use an efficient strategy, which is a strategy that is quicker because we want to be fluent at math just as we are in reading. Okay, so you have the problems up to 3 on the first page, and on the next page you have question numbers 4 through 7. I'm going to let you do those on your own. And at the bottom it says, how is solving 6 take away 4 the same as 9 take away 4? How is it different? Okay, well, you know that 6 here is your whole and 4 is your part that you're taking away. And for this problem, your whole is 9 and 4 is the part you're taking away. So both equations are taking away what? They're both taking away 4. Okay, so that's how they're the same, but they're different because they each have a different what? Whole. That's right. The whole here is 6, whereas the whole here is 9. And 6 take away 4 would be what? Think about that. What does 4 need to get to 6? 4 needs 1 more to get to 5, and then 1 more to get to 6. So you start at 4 and count up, and your answer is what? 2. That's right. And here you can start at 4 and count up to 9. Okay, so 4 needs 1 to get to 5, 2 to get to 6, 3 to get to 7, 4 to get to 8, and then 5 to get to 9. So 4 needs a 5. Okay, so 9 take away 4 is 5, whereas 6 take away 4 is 2. Okay, so the other parts are different. You only have one part that is the same, the other part is different, and the wholes are different in those problems. Okay, I hope you guys enjoyed the math lesson today. I hope you guys have a great day.